Hi, everyone. Thanks for coming today. And I'll be starting off by talking a little bit about the Cosmoglobe Sky Model and how it relates to sort of galactic foreground physics in general. So as we've talked about on Monday, this is sort of the general Cosmoglobe framework. Given data, you iteratively do the map making process, then the component separation process, power spectra, parameter estimation, etc. And so this, this is basically gives you everything that you would want to know throughout just Monte Carlo sampling and the Gibbs chain. And this chain is actually a product that we will be releasing sort of for every extra data set that we add. And like we're on like our Beyond Planck runs right now. There was Beyond Planck run 8 that was released in the release conference in December and currently on 9. And so eventually we'll make these public as part of our products. However, I assume that most of you here don't want the full Gibbs chain because that includes things like the gain as a function of time for the Horn 22S or the FNI. In general, I assume that mostly like you'll want products like what are the amplitudes of the components, what are the cosmological power spectras and the cosmological parameters. And if you're interested in sort of seeing like what is the uncertainty of something, this is a lot to wade through if we just gave you a raw chains file. To deal with that problem, we've sort of created this Python module that's the software's development is being led by Matt Nissan and Trygve Stalheim, both graduate students here at the University of Oslo, PhD candidates. And basically this Sky model or this Python module is an interface to the Monte Carlo chains. And so what we're going to be doing is allow you to explore the physical posterior distribution of fits to the data and essentially be able to predict what an experiment will be able to observe or what the underlying physical parameters on the sky are based solely on the Gibbs chain and the data from the experiments. And then the final product of these would be like posterior means, which would probably be close to what the end user would want. And this posterior mean could be used by any other third-party software. And so this is an active field of development. As you can see, it's still in the beta version. But so that does mean if you are interested in seeing where this goes and influencing its development, we're happy to take feature requests. And so there's a lot of cool stuff to do here, but I'm not going to spend a whole lot of time talking about that. Stay tuned. Now, one of the things that we do here, so as we talked about before, the sort of the machinery of Commander and then the Beyond Planck product are these component maps and these fits to each of these parameters. So for example, the CMB, synchrotron, free emission, spinning dust, thermal dust, and point sources, all parameterized in these ways. And this is just in the current version. In future versions, you could imagine wanting to add different components such as zodiacal light, the cosmic infrared background, carbon monoxide emission lines, or lensing of the CMB and the Sunyaev-Zeldovich effect. And so the purpose of Cosmoglobe, of course, is like you want to add as many components as possible and also add different types of models. And this question about like which other types of models is something that actually requires a lot of expertise, and motivating a physical model is something that having a well-motivated physical model is something that we want that does not necessarily fall under the purview of Cosmoglobe per se. Basically, we need a physical model, and this is my stupid little joke saying that basically introducing Brendan Hensley and Susan Clark, who are both the leaders of the Pan Experiment Galactic Science Group, who I'm sure can explain the gestalt of their group much better than I can. So with that, I will say, Susan, Brendan, please please tell us about the Pan Experiment Galactic Science Group.